Hey, it's Mr. E here, and our aim for this video is how do we simplify exponential expressions? All right, so we have to go over 4 basic rules of exponents. So let's go over the 4 basic rules. All right, the first rule we use to multiply exponential expressions with the same base. So x to the a times x to the b is equal to x to the a plus b. So maybe some of you have seen this before. Whether you have or you have not, I'm going to show you an example anyways, just so it could be clear. Say you're going to multiply x squared by x to the third. Well, according to this rule, when you multiply exponential expressions with the same base, what you have to do is add the exponents. So this is going to be equal to x to the 2 plus 3, which is equal to x to the 5th. Let's look at the other rule. Here we got x to the a inside parentheses, and we're raising that to the b. So the rule says when you do that, it's just x to the a times b. Let me give you an example just to make it more clear. So for example, you got x squared inside the parentheses, and you're raising that to the third power. So it's like you're multiplying x squared by itself 3 times. Using the first rule that we learned, x squared times x squared times x squared, that's equal to x to the 6th. Or we could just use the second rule as a little shortcut here and just do 2 times 3, and we're going to get 6, and so we get x to the 6th. So you could just write it all out and then add the exponents, or you could just multiply these two numbers to simplify it. Okay, the second rule, we use it for dividing exponential expressions with the same base. So it says x to the a divided by x to the b is equal to x to the a minus b. So it's the opposite of the first rule, the multiplication rule, right? When you multiply, let's go up, see if I could go up a little bit here. When you multiply, you add the exponents. When you divide, you're subtracting the exponents. So let me give you an example. Say you got x to the third over x squared. That's going to be equal to x to the 3 minus 2, which is equal to x to the 1, which is just x. Okay, the last rule we use for making exponents of a exponential expression positive. So here's how it works. If you have a negative exponent in the numerator, see this is a numerator here, right? Because it could be over 1. So that's a numerator. So if you have a negative exponent in the numerator and you want to make it positive, all you have to do is just move it to the denominator and make it positive. So x to the negative a is equal to 1 over x to the a. So for example, x to the negative 3. I want to make that negative exponent positive. So what I have to do is move it to the denominator. So I get 1 over x to the third. Let's look at another example. Say you have a negative exponent in the denominator. Well, when that's the case, move it to the numerator and make it positive. So 1 over y to the negative 4th, that's going to be equal to y to the 4th over 1, or just y to the 4th. Okay, let's work out some examples. Simplify the expression completely where all exponents are positive. All right, so when you look at a problem like this and you see negative exponents, the first thing you should try to do, if there isn't any other simplification that you have to do here, is just make them positive. So what do I have to do to make these exponents positive? Well, let's look at the rule we just looked at, the last one. This rule over here, that's the one we're going to use. So if I want to make these exponents positive, this has to go to the denominator. So does this, and so does this. And then this, x to the negative 8, has to go to the numerator. So let's go ahead and work that out. So x to the negative 8, that's going to go to the numerator as x to the positive 8. And then all these babies here are going to go to the denominator as positive with positive exponents. So I'm going to get x to the 1, y to the 6th, and y to the 8th. So see what I did there? I made all the exponents positive just by switching them from numerator to the denominator and vice versa. Now I could just simplify. So I could simplify this over here. That's going to give me y to the 14th. So I got y to the 14th here. And then I can also simplify this, x to the 8 over x to the 1, x to the 8 over x to the 1, that's equal to x to the 7th. So that's my final answer. I got x to the 7 over y to the 14th. Let me just rewrite that in case that's not legible. So it's x to the 7th over y to the 14th. Okay, one more. Simplify the following expression completely where all exponents are positive. Whoops, excuse me. Let me read that again. Simplify the following expression completely where all exponents are positive. All right, so don't want to switch anything around yet because I got this thing going on here. I want to simplify that first. So to simplify that, I'm going to have to use this rule over here. Remember it? I'm going to use that rule. So it's going to be, actually, before I use that rule, let me explain something to you. So 2 to the y, 2 times y to the negative 9th inside the parentheses raised to the third power. It's like saying 2 to the third power, because you got to take that 2 here and you got to raise it to the third power, and you got to take the y to the negative 9th and you got to also raise that to the third power. So that third power, it applies to each individual term. So make a note of that. That's important. You know, most people they won't do the 2 to the third part. They'll just do the y to the negative 9th to the third part. All right, so 2 to the third, that's just 8. And then y to the negative 9th raised to the third power, that's y to the negative 27. So in the numerator, we have 8y to the negative 27. And in the denominator, I'm just going to rewrite it, x to the 7th, y to the negative 8th, and z to the 7th. Okay, so now let's see if we could simplify anything else. No, there's nothing else to simplify. So now let's just make all the exponents positive. So I'm going to get 8y to the 8th, because I'm taking this y to the negative 8 and moving it to the numerator to make it positive. And I have x to the 7th here. It's going to stay right where it is because it's already positive. And now I'm going to take this y to the negative 27th here, and I'm going to write it here as y to the positive 27. And I got z to the 7th here. That's going to stay right where it is because it's already positive there. So I just moved the expressions with the negative exponents around so they could become positive. All right, now let's simplify this. Y to the 8th over y to the 27, whoops, y to the 8 over y to the 27th, that's y to the negative 19th. So now I got 8y to the negative 19th here over x to the 7th, z to the 7th. But all the exponents have to be positive, so I'm going to have to move that y to the negative 19 to the denominator. So I get 8 over x to the 7th, y to the 19th, z to the 7th. And that's my final answer. Hope this video helps. Take care.